the next thing that we're going to attack is a curious type of programming that's available in some languages called nested subprograms. And the stack. All right, so first disclosure, most C-based languages do not support nested subprograms, but some modern languages such as Ada and JavaScript do support it. So what I want to do is I want to show you how the stack can support nested subprograms and references from inner subprograms to variables that were declared in subprograms that they're nested in. So I'm going to write some code that shows this happening in Ada. So procedure A is we have X, which is of type integer. And then we have procedure B is, and then we have another X, which is of type integer. And then we have a procedure C, and we have some code in here, and then there's a reference to X. X equals X plus 1. And procedure B makes a call to C. And then we're going to end procedure B. And then procedure A makes a call to B. And then we're going to end procedure A. Okay. So the thing that I want to attack here is how is it that the stack supports this statement, X equals X plus 1? How does the stack allow us to figure out that the X we're referring to is this X, the X in procedure B? How do we know how to find it? Okay. So the way we do that consists of computing something that's called a static reference. So the static reference allows us on the stack to find the subprogram that the current subprogram is nested in. And there's a set of calculations that goes into using that static link and a set of coordinates for where variables are located inside your subprograms that are used with that static link. So the way we're going to go about doing this is we're going to compute first the coordinates on the stack for each of the variables in the subprogram. And then once we have those coordinates, we can look at the layout of a stack example, and we can see how we can use a special link called the static depth to find the stack activation record that we need to locate the variable that we need inside a nested subprogram. Okay, so the first thing that we're going to do is we're going to compute the static depth. So you can compute the static depth visually, all right? So it's pretty easy to see that A encapsulates B, which encapsulates C. All right, and I can give each one of these subprograms a static depth value. So A has the value of 0, B has the value of 1 because it's nested inside A, and C has the value of 2, the static depth of 2. Now this computation of the static depth is done at compile time. All right, so the next thing that we're going to do is we're going to compute the chain offset. So the chain offset is computed for every single variable reference that we have. And the chain offset is the distance in activation records from the reference to this variable to where the variable was actually defined. All right. So if we have a local variable, the chain offset is going to be 0 because the variable is defined in the current activation record. But if we have a variable that we're referring to that was defined in a different subprogram, then we have to calculate the distance between the current subprogram we're in and that subprogram that defined that variable. And it could vary depending on which reference we're making. And the key to computing that chain offset is looking at the static depth difference between the subprogram that we're in and the subprogram that defined the variable. All right, so let's do some examples here. Well, I'm going to show you the formula first. So the chain offset for any variable is equal to the reference, the variable reference, static depth, minus the variable definition, static depth. Okay. So, and you do this for every single variable that you have. So for example, C's or let me rewrite that. The X in procedure C, chain offset, is calculated by saying, well, the variable reference static depth of the X in C, the static depth of C is 2, right? Because that's right there, 2. And, oops, I did that wrong, sorry. The static depth of, no, I did that right. It's 2 minus the definition variable definition static depth. Well, the static depth of the variable that we're referring to is the variable's definition occurs in B, and the static depth of B is 2. So that means that the chain offset for C is 1, for the reference to X in C is 1. And that makes sense if you think about it. If we're careful about how we construct the activation records on the stack, when we refer to this X, we're going to have to jump down one activation record to get to procedure B to find the actual variable X defined in procedure B. And we'll take a look at an example of that as when we build the activation records at the end. Okay, so that's part one. We're going to compute the chain offset. Now, one last example, X in B, chain offset. So if we're talking about X inside procedure B and we're saying, hey, where do we have to go? How many activation records do we have to go jump through to get to the definition of the variable X in procedure B? Well, the variable X is defined in procedure B. So we can just write it out. The variable reference static depth is 1. Oops. And the variable definition static depth is 1. So the chain offset for X and B is 0, and that makes a lot of sense. We don't have to jump out of the current activation record to find the definition for X in procedure B. It's defined in procedure B. All right, so I said that for every variable, we're computing a set of coordinates. So coordinate implies that there's 2 values that are necessary to locate a variable. So one is how many activation records we have to jump through to get to the definition of the variable that we're currently referring to in our current subprogram. That's the chain offset. The second thing that we have to do is we have to compute the local offset. And so to do that, I'm going to roll ahead a little bit, which means we're going to lose this program, but we'll come back to this program in a moment. But I want to actually write a little bit more code. Just give you another sample program. Let's say I have a procedure. Well, let's do this. Let's say I add this procedure, big sub, to the end of the code that's right here. So outside procedure A, I have a procedure big sub is, and then I define an X, a Y, and a Z as integer. And then I have a begin, some code, and an end. All right. Now, in addition to computing the chain offset, once we've gotten to the activation record for the variable, because we're where we need to be, where the variable was defined, so we can go look up its value, or we can change its value, or whatever, we need to find the variable within that activation record. So that's the second part of the coordinate. So we're going to do something called compute local offset. All right, so how do we compute the local offset? Well, let's zoom in and look at the activation record for big sub, all right, as an example. I chose big sub because I wanted to have a bunch of variables to show that you have to look around a little bit in the activation record to get to the specific variable on the stack, all right? So here is my stack for big sub, my activation record for big sub. I have a return address. That's at the bottom of the stack. I have something called a static link. So I'm going to draw out that static link in just a little bit, but the static link is the, up a little bit higher here. I still want to see the code. There we go. Okay. All right. So the static link is a reference to the activation record of the subprogram that the current subprogram is inside of. All right. Okay. And we'll see that in a moment. All right. The next thing I have is the dynamic link, which gets me to the previous, the caller's stack, or the caller's activation record. And then I have local variables. So I have X, Y, and Z. So I'm going to say I have a local variable X, a local variable Y, and a local variable Z. Okay. And so if I want to figure out what the local offset for the variables that are defined within a subprogram, I'm going to just label each of the slots in the activation record for big sub, and then what I'm going to do is say, well, here's the variable name. So we have X, Y, and Z. And here's the local offset. And the local offset is for X, the local offset is 3. For Y, it's 4. And for Z, it's 5. And while I'm at it, I might as well write down the chain offset as well. I'm doing some clever things here, which I'm sure if you're taking notes, you find a little bit annoying, but generally when we're specifying the coordinates, I have like an X and a Y, you specify the chain offset and the local offset together, but you do the chain offset first. So I just moved them around. So the chain offset for all of these is 0 because they're defined within this subroutine. But you can see, like every variable reference, if you've got the chain offset and the local offset within the activation record, you have the coordinates for that variable in the activation records. All right. Okay. So let's go back to this procedure here, or this code here. I'm actually going to grab it and pull it down, make a copy of it, so we can compute the chain offset and static offset for this code. So copy, paste. Okay, got a little bit of debris there. All right, so what I want to do is for the X in, for the X in procedures, for the X defined in procedure A, procedure B, and the reference in procedure C, I basically want to compute the chain offset and the local offset for each, okay? So I'm going to put down variable. And then I'm going to put down the chain offset. And then I'm going to put down the local offset. For these variables. So I have, I've got A's X, I've got B's reference to X, and I have C's reference to X, all right? So that's the variable. The chain offset is fairly easy to calculate because what you're just looking at is the difference between the static depths of each of these procedures. So the chain offset for X in A is chain offset for A's reference to X. The chain offset is 0. It's the static depth of A, which is, it's the static depth of A, which is 0, minus the static depth of the reference to X, which is 0 in A, and the definition of X, which is also 0. So the chain offset is 0. The chain offset for the reference of X in B is also 0. It's the static depth of B, which is 1, minus where X was defined, minus where X is used, that's also in B, that's equal to 0. We already did the calculation for C's reference to X, but it's worthwhile doing again. It's the static depth of C, which is 2, minus the static depth of the definition of of x, which is defined in subprogram B, which is 1, that gives us 1. Okay. Now, the local offset is once you're in the activation record for the subprogram that's defined the variable, where is that variable located? All right, to get the local offset, what I'm going to do is I'm going to draw the set of activation records that leads us to this line of code. All right, so it's A calling procedure B, which is calling procedure C, which eventually gets to this line of code right here. All right, so to do that, that's really going to help us a lot, revisiting the chain offset and also helping us to compute the static offset. All right, so let's see. So let's talk about, whoops. So let's talk about, let's create the stack for A first. We'll build it up from A. So here is the stack for A. We've got a local variable. And that variable is X. And that has an offset of 0 from the beginning of the stack, because the only thing that's on the stack for procedure A, let's pretend, for procedure A, let's pretend this is the only code in the system. We just have that local variable. When we return from procedure A, we're done with the program. All right, so the local offset for procedure A then is 0. So then the coordinate for X is 0, 0. All right, now, I need a little bit more space over there because I'm going to do something funky as well. Okay, cool. All right, now let's create the activation record for B. Well, one of the things B has to have is the return address to get back to the code that makes procedure A work after the call to B from A. All right, so we've got that. Then we also have something called a static link. So the static link is a way to find the beginning of the activation record for the subprogram that the current subprogram is nested in. Well, the static link for B is going to take us to the beginning of the activation record for A. We also have a dynamic link. The dynamic link gets us to the activation record of the calling subprogram. So sometimes the activation record of this of the calling subprogram is the same as the static link, but sometimes it's not, and we'll see examples where that happens. So the dynamic link is going to get us back to also to the activation record for. Oh, you know, I think I did this a little bit differently with the dynamic link. I put it to the top of the stack. It doesn't really, I don't think it really matters. We just need to find that activation record. But I'm going to put that here anyway. So we're getting to the top of the stack of the caller. Now remember, in this case, the static link and dynamic link basically go to the same activation record, but that's not always the case, and we're going to see that in a moment. Okay. So in addition to the dynamic link, we have a local variable in B, which is X. And the coordinate for X is a little bit different here. So we've got 0, 1, 2, 3. So X is the fourth thing on the stack for procedure B. So the local offset for X then on procedure B is 4. So the coordinates for this X are 0, 4. For any reference to X inside procedure B would be 0, 4. Okay, so let's do procedure C. So actually, I'm just going to label this a little bit. So this is the activation record for procedure A. This is the activation record for procedure B. And now we're going to look at the activation record for procedure C. Okay, so first of all, we're going to have a return address. And that's going to allow us to return to the code for procedure B, which was the caller. All right. And the next thing that we're going to do is we're going to have the static link. And that static link is going to get us to the activation record of the subprogram that encloses procedure C. All right. So that's going to take us down here to yeah, that's going to take us down here to the start of the activation record for procedure B. And then we have the dynamic link. And that takes us to the top of the activation record for procedure B. So that's going to take us, whoops, that's going to take us to here. All right, and then we have, well, we don't really have anything else. I can label this 0, 1, and 2, but the reference of C's X is going to be, well, let me just write this down as well. Let's see. The reference to C's X is going to be the chain offset of 1. So we're going to move down. We're going to move down 1 to this. Oops, that's the dynamic. Sorry about that. We're going to move down 1 static link to get to the beginning of B's activation record. And then we're going to use the local offset of 4 to get to the actual definition of X. So we're going to move up 0, 1, 2, 3, which is 4. Oops, I think I screwed this up. Those are supposed to be 3, not 4. Sorry about that. So 0, 1, 2, 3, that will get us to the definition of the X that C is referring to. So in this case, any reference to X inside procedure C is going to have a coordinates of 1, 3. Down 1 chain offset, 1 static link, and then find position 3 in the activation record for the subprogram. Okay, well, that takes care of our discussion of chain offsets, local offsets, and how nested programs can be supported by a stack.